Hello again, it's Dr. Pete. We're talking comfortable universe and our song of everything, and today we're going to even drill down a little deeper in our song of everything's simplest possible universe beginning scenario. How did our universe start? How did the simplest possible version of our universe start? Well, we got to start somewhere, and so of course we talked about starting with the big V vacuum, which we take on faith as being something that preceded or resulted in our universe. So if that's the case, what came out of the big V vacuum first, and what is the simplest way it could create a functioning, useful universe? Our universe chose out of what is, I claim, what the big V vacuum ought to have, just a library of just about anything you can imagine, just anything possible could have been the ingredients that started our universe, but our universe chose this thing, this pair of things or thing called space-time, or space and time. And not necessarily the unified thing that general relativity shows us exists now in our current universe. So we're going to start by talking about space. How do you get space to make any kind of sense? Well, it's a pretty simple thing. Space is how you define a relationship between two things. Thing A here, thing B over here. Thing A and thing B are related to one another by being separated by a certain amount of space. If you don't have space, you just got a thing, and the big B vacuum is just full of those kind of things. They didn't turn out to be useful, or at least not in their raw situation inside the big V vacuum. So you get space. Thing A and thing B are sitting there. Well, if they don't relate to each other, you still don't have anything useful. Thing A's over here, sitting there, doing nothing. Thing B's over here, sitting there, doing nothing. They're not talking to each other, not doing anything related to each other. So you just have two chunks of things sitting there in a useless space. In order to get space to function in some kind of a useful way for a universe that actually does stuff. I mean, you could have these universes with things hanging around in space, all these little dots around in this space, and they're static and they're just sitting there forever, but who cares? It's not what we got. So you need something that is like time, that makes objects interrelate with one another and do stuff. Well, let's take a step back, because we've got this thing called the yin-yang particle, the yin-yang-on, which is a quantum particle which came out of the vacuum, and we've defined it as having a thing A and a thing B, and a connection between them being a spring, which is really the representation of the quantum field that really is the total description of thing A and thing B as a unit. So it's not the simplest possible thing, but it's the simplest. I mean, just a dot in the vacuum is a simpler thing, but it didn't work. It doesn't work. So the yin-yang-on does have what you would define as a relationship between thing A and thing B, and that's that field, that spring between them. The field is there, and it's not only between the two particles, but the yin-yang-on is a thing that is space ready. It's ready for space to be manifest by having a separation between these two things and a quantum field defining the connection between them. And that's why it's critical that we start with quantum mechanics. It's the only way to have a space come into being that is going to make any kind of sense and be in any way useful. So, we've got our yin-yang space ready, all built up. Maybe even that took many baby steps to get to it in the formation process of our existing universe. Steps that I have no way of defining. That our Song of Universe is just going to say, well, yes, that happened. But there's our yin-yang on, and the next thing that comes along is our balloon squeezer, our Qi-on, named after Qi or Qi, Qi, which is the vital force in the Chinese language. It's the thing that gives us life, so to speak. And yes, the Qi-on comes along, balloon squeezer, trying to squeeze and expand that yin-yang on until it, or making it, come to life. The the balloon squeezer then is kind of stupid. It doesn't know all the stuff that it's doing. It's sort of manifesting time, and it's allowing space to come into being by activating the space-ready yin-yang on, but it's pretty stupid. It takes the one part of it, the squeezer, takes the yin-yang particle and squeezes it and says, you're in no space. You're not in space. I'm squeezing you down to one thing and I'm keeping you there. I don't recognize time as operating on you. I'm keeping you squeezed. And that's the inflation particle. The cause of inflation is that squeezing of the yin-yang onto a really high energy state. Meanwhile, the other part of the yin-yang on is complaining. It says, I'm here too, just look at my quantum field. You can't just squeeze one part of me and say that's all there is. So I'm gonna keep you at bay. I'm gonna keep away from you. And that's how time is defined. Time is defined as objects relating to one another by moving in relation to one another. So in this simple universe, we have the squeezer squeezing the yin-yang on into a tiny inflating particle that can't get out of it because the squeezer won't let it. The squeezer doesn't even know how to let it. It just squeezes and squeezes forever. And so there you go with your, well, not forever, but we'll talk about that in a minute. So there you go with your inflation developing. But meanwhile, in some abstract space beyond the inflation, the yin-yang on's quantum field is keeping the other aspect of itself at bay, away from this inflation field. So again, the balloon squeezer is saying, I don't understand what time is about. I'm just squeezing you forever and you're going to stay squeezed. But the other part of the yin-yang on says, no, I'm running away from you. I'm manifesting time. I'm making time happen, and that's how I can keep away from you, by going as fast as I need to keep away from you. How fast is that? Well, that's the speed at which inflation is inflating, or, just beyond that. So the other side of the particle, of the yin-yang on, stays beyond the inflation. And it's moving at this speed, which we know from our observable universe is way faster than the speed of light. And we also have identified the squeezer as being the particle that exemplifies gravity, exemplifies the general relativity concept that maybe becomes gravity. It's squeezing, and its intrinsic nature is that it follows the rules of gravity, and gravity travels at the speed of light. And God said, "Let there be light." It was not actually light, it was just the speed at which gravity traveled first and foremost. Light, the actual stuff that we call light, came later. So here we have this yin-yang squeezed particle creating inflation, and it's just, the squeezer is just sitting there, but it's representing the speed of gravity. And you know, when you look at two objects that are moving relative to one another, you can use any reference frame you want. So you can say that one is standing still and the other is moving away from it, or you can say the two are moving apart, or you can say that both of them are moving along in the same direction, but one's faster than the other. Well, it's the easiest to take one of them and say it's not moving at all. And that's totally representative of the point that a particle like a photon, or the graviton, if that exists, or the force of gravity, moving at the speed of light, our laws of general relativity tell us that those things that are moving at the speed of light don't experience time. The passage of time doesn't exist for them. So there's the inflation sitting there still motionless, in the sense of not recognizing the passage of time. And our other particle, the other half of the yin-yang on, is racing away from the inflation at the speed which is way faster than that speed of light, obviously, because it's, in this reference frame, it's motionless. And so what you now have, if you followed this picture, is you have a universe with two different speeds, and that's it. It only has those two different speeds. It has the speed of light and the speed that the inflation is expanding space. Well, is that speed definable? Is it infinite? It's a little bit questionable, and our Song of Everything doesn't have like the final answer on this. But right now, my best answer is that it's not infinite, because there's nothing infinite. Infinite is an abstract concept, and Song of Everything operates on the assumption that there are no abstracts in the real physical world. You can think about them, you can talk about them, but they aren't physical. So the universe is expanding way faster than the speed of light, and the yin-yang on is one side of it is sitting stationary, the other side of it is moving way faster than the speed of light. But you got to bring in the how did this ever start in the first place? How did it get allowed to happen when the big V vacuum wants chaos, wants everything to be destroyed? And so we've talked about what I'm calling the vacuon, a brief statistical anomaly of lack of speed, of lack of chaos in the big V vacuum. And the amount of that, the amount of not time, but just sort of the intensity of that vacuon, and the vacuon is a play on the Chinese word yuan, which is origin, means origin. So the vacuon is making this happen, but it isn't infinite. Eventually it's going to chop down, it's going to close down, and the chaos is going to return. And it's sort of like the bigness or the extremeness of that vacuon's quiet space or moment. It's neither, of course, because it's in the vacuum, but that has a size or a probability, and that depends on how intense it is, in a sense. So I'm guessing that the speed at which the inflation expands is related to the size of that vacuon. And it might be that little teeny tiny vacuons are what are creating dark energy. That's really off on the side of what we're talking about today. I need to end this because my recording device does not record long videos. It suddenly shuts down, and boy, if that happens, I'll be pissed. So we'll keep pursuing this. It's great fun, love it. Hope you do too. All right, take care, bye-bye.